Hi everyone! Today we are going to be continuing our learning journey around parallelograms and area. But today we're going to be learning how to find the missing dimension of a parallelogram. So the information that they're going to give us is going to be one of the dimensions, so either base times height, and we're going to have to, and the area, and we're going to have to find whatever's missing. So we're going to continue to use our formula of area equals the base times the height. That's our formula, and we're going to continue to use this formula to solve any and all problems. So let's go ahead and take a look at problem A. Problem example A has a parallelogram that looks something like this. Something like that. And it tells us that here's the height. And the height we don't know. So there's the height. We don't know the height. It says that the base is 16 feet, and then it says that the area equals 80 feet squared. So we're given two things, and we have to find or solve for the height. So first, let's talk about what we know. First of all, we know that the area is 80. So in this formula, where I see the A for area, I'm going to just put the number 80. So 80 equals, and then I don't know the height, but I do know the base of this, which is 16. 16 times h. Now, if you think back to a couple lessons ago, or maybe a while ago, when you're trying to solve for a missing variable, we had to isolate the variable. So we're going to do that same thing. Now we're going to build on what we've learned in the past by isolating this variable. So right now it's multiplying. So to undo multiplication, we're going to use division. So we're going to divide by 16, and we're going to divide by 16. This is going to give us the h, and the height is going to equal let's get this into our calculator. 80 divided by 16, and that equals 5. So it equals 5. So the height is 5 feet. It's not squared because it's one of the dimensions that you would use to multiply. So we can check this by saying 5 times 16, and we can see if we get 80. So we could do 5 times, sorry, my dog just scratched me, 16, and we get 80. So we did do it correctly. 5 times 16 gives us 80. There we go. Okay, let's do another example. And in this one, in this example, it wants us to find the base of the object. So example B looks like this, and it has dog hair on my paper because my dog is right here trying to do math. Okay, again, we don't know here's the height. It says that the height is 3 kilometers. And this time it wants to know the base. So we're solving for x or the base. We don't know the base. If we were to flip this over on top, it would land on the x. So it says that the area equals, what does it equal? (16 kilometers squared). Okay, so our job is to put in what we know. So we know that the area is 16. So where I see this formula, I'm going to put in area equals base times the height. I'm going to put in what I know. So I know 16s for the area, so where I see area, I'm going to put 16. I know that the height is on the right angle. The height here is on the right angle, so where I see height, I'm going to put a 3, and I still don't know the base. However, I am ready to solve this by undoing with opposite operations, right? My job is to isolate this variable, and the variable is the base. I could have left it as x. They mean the exact same thing. So if this b is confusing you, just change it to an x since you're solving for x. So right now it's multiplication. To undo multiplication, I use division and division. So base equals 16 divided by 3, which is going to give us a decimal. Oh, that's a really long decimal, so we're just going to do 15.33 since it's repeating. I mean 5.33. Oh my gosh, I can't read today. 5.33. So base equals 5.33 repeating. That little symbol means repeating. And these were kilometers. Those were kilometers. Okay, let's try and do one more. So let's go ahead and try to do one more. On this one's a real life situation. Okay, so on example C that they have for us, this one gives us a real life situation. And in this real life situation, they have a street going this way. So here's your dotted street going that direction. And it's parallel another street going this way. There's our parallel street. And then it has a street going this way. Oh my goodness. Okay, and then guess what? Oh, look at that. Another street going this way. So in the middle here, this area, if you notice, is all green. And they say that this is like a forest. Okay, so you've got some trees in here. Remember, this is a real life problem. Okay, and in our real life problem, it has a deer trail. So on here, there is a deer trail right there. Deer trail. Okay, let's see. That's our deer trail. The height is on the deer trail. Now, it tells us that the length of the road is 660 yards. And it tells us that this whole area here, the whole area of the forest, the area of the forested area there is 99,000 yards squared. So our job is to find the length of the deer trail. Okay? It works the exact same way. We're still using this formula. Area equals the base times the height. Okay? We know the height is on the right angle. So it doesn't matter what letter this is. The height is always going to be on the right angle. It just happens to be a deer trail. So we could use D for deer trail. We know that then the base is going to be 660. And the area they tell us is 99,000. Again, we're going to solve this the exact same way. We're going to isolate that variable by using the opposite operation. Right now, it's multiplying. So to undo multiplication, we need to use, you are right, division. So we're going to divide and divide by 660. This leaves us the length of the deer trail once we solve this. So let's grab our little calculator here. We're going to put in 99,000 divided by 660, and this is going to give us 150 yards. So the deer trail equals 150 yards. Doesn't matter if this is a real life problem or if it is a problem that looks just like this rhombus here, not rhombus, oh my gosh, parallelogram. It's still a parallelogram because it's slanted, it runs at an angle. It works the exact same. Base times height, you're just finding the area of the forest. Okay, go ahead and finish writing this down. Hit pause if you need to. I'm going to turn the page right now so that we can do some try-its. And then we're going to see what we have going on there. All right, so for your try-its, all right, pen is stuck in my paper. Let's pull up your try-its. Give me just 1 second. All right, try-it number 1 is a parallelogram that happens to look like this. And they tell you that this slanted part right here is 7 inches. They tell you that we don't know this height. And then they also tell you that this number right here is 8 inches. Again, you have 3 different dimensions here. Determine which one you need to use in order to solve. It says that the area is 48 inches. So use the correct things. One of these is trying to trick you. Don't let it trick you. Don't let it trick you this time. Okay, and then try it number 2. Try it number 2. We have a parallelogram that looks like a swimming pool that looks like a parallelogram. So here's our swimming pool. It looks like a parallelogram. It has a walking bridge that goes across. So here is the walking bridge. And that walking bridge is unknown. However, this length right here is 50 feet. The base is 50 feet. It says that the area of this swimming pool is 1,800 feet squared. So your job is to find how long the walking bridge is with this given information. Okay, go ahead and hit pause right now so you don't hear me solving, and then when you're ready, come on back and hit play. All right, so first of all, we know that area equals base times height. So I'm going to plug in the things that I know. I know the area is 48, so where I see area, I'm going to put in 48. I know that the height is on the right angle, so here's the right angle. The height is x. Now the base. If this is the height, this is not going to be the base because this is on the slanted part. We want this one right here that's either on the top or the bottom. So this one's going to give us 8. We're going to divide by 8 and divide by 8. So x equals 6. So our height equals 6 inches. How did you do on this one? How did you do? Okay, on number 2, let's check out number 2. Again, we're still using area equals base times height. Okay, we've got a walking path now. The height is on the right angle, so where I see H, I'm going to put a W because walking path. The base, the bottom is 50. And my area is 1,800. I'm ready to solve. I need to isolate this variable by using division and division. So this says that W equals 1,800 divided by 50. So let's go ahead and pull this out. 1,800, nope, divided by 50 gives us 36. So the length of the walking bridge is 36 feet. Okay, how'd you do on that one? Go ahead now and answer your essential question. How do we find the missing dimension of a parallelogram? It's all in the formula. And then put your level of understanding out to the side. Where are you at? When you are ready, you can either come on back to the Google Meet and ask for help, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.